Now in this question they say an object 4 centimeter high. So they have given you height of the object. Let it be represented by O, which is 4 centimeter. That's the height of the object given. And this object is placed at a distance of 40 centimeter. So that's the object distance which is represented by U. So it will be minus, U is always negative, so minus 40 from the optical center of a concave lens. Now it's a concave lens, so focal length will be, it's a concave lens, so we are going to take the focal length as negative, minus 20. So they have given you height of the object 4, distance of the object, that will be negative, minus 40. It's a concave lens, so focal length will be minus, so minus 20. Now they have asked you to calculate the position of the image. So we can use the formula 1 upon f, 1 upon v minus 1 upon u. So let's use this formula. So in place of f, it will be minus 20. V we have to calculate, and u is minus 40. So this will be minus 1 upon 20 is equal to 1 upon v, and this will be plus 1 upon 40. Now this plus 1 upon 40 will be subtracted. So this will become minus 1 upon 20 minus 1 upon 40 is equal to 1 upon v. So taking the LCM over here, LCM will be 40. So this will give you minus 2 and then minus 1. So 1 upon v. So we are getting minus 3 upon 40. So solving here, you will be getting value for v as minus 40 by 3. So that can be written as negative 13 whole number 1 by 3 centimeter. So this we have got v. Now what v represents? V represents distance of the image from the lens. So you can say position of image is is 40 by 3 centimeter. And what does this minus sign indicate? This minus sign indicates that the image is formed on the same side as the object. So position of image is 40 by 3 centimeter from the lens, and then you can add for this minus sign on the same side, as the object. So whenever you get v as negative, while writing the answer, don't write negative sign, but instead you will write that the image is formed on the same side as the object. So that was the first part. Now in the second part, they have asked you to calculate the size of the image. Now when we have to calculate the size of the image, first we will calculate the magnification. So magnification formula will be v by u. So magnification v by u, v we have calculated minus 40 by 3 upon u, u is minus 40. So when you simplify it, you are getting magnification as plus 1 by 3. So that's the magnification. Now the second formula for magnification is in terms of size of the image to the size of object. So we were asked to find the size of the image. To get the size of the image, first we have got the magnification. That's 1 by 3 using the formula V by U. Now the second formula for magnification. Let's substitute the values. M is 1 by 3. I you have to find. O is the size of the object. So size of the object given to you is 4. So from here you can say image size is 4 by 3 centimeter. So we have got size of the image. Now the third part says you have to write down the characteristic of the image. Now if you see that the image is smaller in size to the object. Object is 4 centimeter, image is 4 by 3 centimeter. So image is smaller. So you can say image is diminished, or you can read the magnification. Magnification is magnific. So here magnification, as you can see, is less than 1. So whenever magnification is less than 1, remember image is diminished. So you can say image is diminished. As the magnification we have got positive, so you can say image is virtual. Virtual image is always erect. So we have got diminished image, it's a virtual image as well as erect image. Now moving to the fourth part, they've asked you to find the power of the lens. Now to find the power of the lens, first you will convert the focal length into meter. So focal length here is minus 20 centimeter. So we will convert it into meter. So minus 20 by 100. So focal length we are getting as minus 1 upon 5 in meter. Now after getting the focal length, you will take reciprocal of it. So power is reciprocal of focal length. So power will be minus 5 and the unit will be diopters. So the focal length was given to us minus 20, we converted it into meter, and then taking the reciprocal will give us the power. So the power of the lens is minus 5 diopters. See, this was the question, and let's see how we have solved it. Now moving on to the next question. Now in the next question we have a concave lens forms 4 times diminished and virtual image. Now see this one. It's a concave lens which is forming 4 times diminished. The image formed is 4 times diminished. So you can say magnification is 1 by 4. 4 times diminished means 1 by 4 is the magnification. Now magnification will be having either the positive sign or the negative sign. So if image is virtual, then the magnification will get positive sign. So you will say magnification is plus 1 by 4. Why? Because the image formed is virtual. So as the image formed is virtual, so we are going to take positive sign for magnification. Now what else is given? An object is placed at a distance of 80 centimeter. So that is u, given to you minus 80. We have to calculate the position of the image. Now see how you will calculate the position of the image when magnification is known to you. We have the formula for magnification as V by U. Magnification given is 1 by 4. V we have to calculate, U is minus 80. So from here you can get V as minus 20 centimeter. So again, as we did in the last question, you can see V, that is the image position, you are getting negative. So what does this negative sign indicate? So you will write image position is 20 centimeter from the lens, and as we have got V with negative sign, so you will say same size as the object. So remember, whenever you get V negative, you will write the statement that it is the same side as the object. Second part, we need to calculate the focal length. Now we can apply the formula for the focal length. 1 upon f is equal to 1 upon v minus 1 upon u. So v here is minus 20 and u here is minus 80. So 1 upon f is equal to, LCM will be 80. This will go 4 times, so minus 4. This goes 1 time, so it is minus 5 upon 80. So when you simplify it, so you are getting focal length 20 will go 4 times in this. And now see, this will become minus plus, so this will be minus 3 upon 80. So f will be minus 80 by 3 centimeter. So we have got the focal length. See here, this will become minus plus 1. Okay, now moving on to the next question. In the next question they have said, we have a convex lens which produces a real and inverted image 2.5 times magnified. Now here magnification is 2.5 times, and now the image is real. So as the lens is producing a real image, so magnification should be with minus sign. Remember, whenever image is virtual, magnification is with plus sign, and if it's a real image, then the magnification is with minus sign. So we have got magnification. Convex lens is producing real and inverted image at a distance of 25 centimeter from the lens. So this 25 centimeter, it is representing the distance of the 25 centimeter from the lens. So real and inverted image, and its distance is 25. So V is 25 centimeter. Now as it is a real and inverted image, so V will be taken as positive. So V will be positive. Now we will be solving this one. So we will use the magnification formula, V by U. Magnification is negative, minus 2.5. V is 25, so you can get U from here. So U will be 25 divided by minus 2.5. So this will give you minus 10. So U means the distance of the object. So object is kept at a distance of 10 centimeter. Now we need to calculate the focal length. To calculate the focal length, you can apply the formula 1 upon V minus 1 upon U. Now V is known to us. V is known to us as plus 25, and U is known to us as minus 10. So you will be getting LCM as 50. 25 goes 2 times. This will become plus, and this will go 5 times. So 1 upon F is 7 upon 50. So the focal length is 50 by 7 centimeter. So this we have calculated the focal length. Now the question says you have to also calculate the power. Now to calculate the power of the lens, first you need to convert the focal length into meter. Focal length in meter. Focal length is 50 by 7. You will divide it by 100 and it will be converted into meter. Okay, so after converting the focal length in meter, now you can take a reciprocal of it and you will get the power of the lens. So that will be 14 and the unit will be diopters. Now as it is a convex, so you will be taking the plus sign with the power. So power will be positive. Now moving on to the next question. Okay, in the next question we have an object of height 2 centimeter. So object height is given 2 centimeter. Just read the question here. Okay, so here object height is 2 centimeter. It is placed at a distance of 8. So object distance, that is u, it is always taken negative, from a convex lens of focal length. Now it's a convex lens, so focal length will be positive. Focal length will be plus 10. Now you need to calculate the position of the image. So we can apply the formula for lens. 1 upon f is equal to 1 upon v minus 1 upon u. Focal length is 10. V we need to calculate. U is minus 8. So it's 1 upon 10. This will become plus and it will be transferred this side, minus 1 by 8. So your LCM will be 40. 10 goes 4 times. 8 goes 5 times. So we are getting V as minus 1 upon 40 is equal to 1 upon V. So from here V is minus 40. Now getting V in minus shows that image is formed same side at the object. So you can say position of image is 40 centimeter and the image is same side as the object. Same side as the object. Now moving on to the second part, they have asked you to calculate the size of the image. So to calculate the size of the image, first we will calculate magnification using the formula V by U. So V here is minus 40 and U over here is minus 8. So magnification you are getting as plus 5. Now using the second formula for magnification, that is I by O. Magnification is 5. I we have to calculate and O is the size of the object, that is 2. So on cross multiplication, image is 10 centimeter. So the height of the image is 10 centimeter. If they ask you to write the characteristics of the image, so you can see image is bigger than the object, so it is magnified image, right? Okay, the image formed will be, you are getting the size of the image as positive, so it's a virtual image and virtual image is always erect. So whenever you do the calculation and you get I, that is the size of the image in positive, so it means the image is image is virtual and erect. But if you get I as negative term, then remember negative over there shows that the image is real and inverted. So these numericals are clear to you, so you can try these one.